actually called What's in My Mobile Geo Toolkit, mostly because I did a talk where they wanted to focus on mobile, but it's relevant to everything. But really it's called What's in My Toy Box. Stuff is going to break, especially with our internet connection. Don't blame me for it. Let's start. So, some of this stuff you'll already know about, some of it you might know about, not know about, some of you've used with me. So ignore me where you already know about it. Who's ever heard of OpenStreetMap? Who's ever used OpenStreetMap?
Have I used it?
Yeah, you've used it in different ways. So OpenStreetMap is just a source of data. I shall go and get one of my mini browser windows open. It's a source of geographic data all around the world that's crowdsourced and is incredibly flexible in its licensing. They're actually challenging its licensing at the moment, trying to make it even more flexible. But pretty much all you need to do is attribute where you got it from, and then you can do whatever you like with it, including sell it and charge it whatever you like, etc. But this is its website. People struggle to tell the difference between the fact that OpenStreetMap is actually a data source and the fact that you can go and see the map of it. But what I guess is truly unique about OpenStreetMap, and if we're really lucky, so compared to Google, in built-up areas anyway, especially in the UK, the data is actually quite often better, because you'll get little footpaths like this that Google don't even know exist, that someone will have contributed. But in some areas it's not. But the great thing, and the point of OpenStreetMap, is I can just choose to edit it at any point I like. In the same way you can with Wikipedia.
And now we have the broadband.
It's
like, oh, it's not that it's not related. You get like little pubs where the pubs.
Yeah, and there are layers to do with cycling, and there's even an open whitewater rafting map that's also contributed. It's been used for a lot of different things, but what I'm showing you here is if I looked at this from Ordnance Survey, which we might see in a moment, you would get all the building outlines, and you don't have them in OSM at my house at the moment, but you do now. Try and work out in my head where that is going. So I've added a new building. I think somewhere in here there is residential. And I can't remember what my other house number's name is, so I'll just leave it like that for now. And that is now saved into OpenStreetMap and will be available to everyone in the world who can download it. Now, hopefully, if we're really lucky and everything goes in another direction, when I come and show you a demo later, you'll see just how cool that is. But I'll explain that later. So that's OpenStreetMap. It has a massive collection all over the world. It's used by tons of products that we'll talk about in a moment. It is, I think, beyond doubt, the future of most mapping that we're going to use as consumers, because it's just going to be so much cheaper for people to use it and more flexible for people to use it. But as you can see, there's a great advantage I can go and edit it, but there's a great disadvantage in that I can go and edit it. That probably wasn't the most accurate drawing of a building ever done, and certainly wouldn't pass any surveying tests. So you get the same problem you get with Wikipedia. You don't actually know necessarily what the quality of that data is, or how up to date it is, or who really did it. It can be maliciously used. People have tried to attack it and alter it in the past, but actually the community have been really good about how they handle that and blocking IPs and being able to roll back. So they're pretty good, probably better than Wikipedia are, because it's real data you can analyse about fixing that stuff. So this is all about open data. So Ordnance Survey are the world's best mapping company in terms of quality of data, and it's reasonably unquestioned, because they're one of the oldest. Certainly they've been around since 1700 or something or other. They were formed so that they could survey the cliffs around the south coast for gun placements, because they thought Napoleon was going to invade. That's how old they are. They have a really detailed process for collecting this stuff. They have amazing data. They are owned by the government, so therefore you and I pay for them. But actually most of their products until very recently were all paid for. They had very restrictive commercial licenses, and they were very, very expensive. So the really, really detailed where every building is in the country costs you multiple millions of pounds to license every year if you wish to use it. So it gets used by people who really need it, like surveyors and stuff like that, but generally us web developers and mobile people stayed away from it because there's no business model that can sustain that. But Ordnance Survey either chose to or were forced to, you can take your pick of that, to release a lot of the data that they collected, where it could be argued that they weren't going to be financially kind of crippled if they did. So unsurprisingly, they don't release their multiple £1 million data set, but they release various different versions of it. And actually, as a web developer doing some mapping, you don't need that level of detail. So you can go to Ordnance Survey's open data page here, which is just open data downloads, and you can get what they call a mini scale, which is a bit like a roadmap. You can get raster versions, so non-vector versions of stuff. You can get a simplified street view, which I think we're probably going to look at here. Actually, that's just weird. You can get things like boundary lines. You can get the location of every single UK postcode. Can't get the address of it. You can get the location of it. You can get pretty much the location of every single populated place in the UK using their gazetteer. It also has forests and stuff like that. They have got some data sets, but they're mostly about roads rather than buildings and stuff. So there's a whole load of data that people don't know. There's even a terrain data set now. So either the data sets they're releasing free are simplified, so in this case it's only down to like 50-meter accuracy, I think, 50-meter grids, or they're data sets that they don't release all of it, like the postcode stuff is only releasing postcode locations, not postcode addresses. They don't own that. But basically by releasing this, they created a whole load of people using it for more interesting stuff, and it was a really good thing to release, and we use it for postcodes and all kinds of stuff. Might use it more. GeoNames. GeoNames is similar to OpenStreetMap in terms of it's crowdsourced, it's very open, it's flexible, but what it is a worldwide gazetteer, so populated places and points of interest all over the world. And they have a kind of freemium model. You can just go and get all the data and dump it into a database or CSV or whatever you like, but they also do offer some limited free and paid for services built upon that. So they've got, and you can go get the code for them. It will do a geocode of, let's give it a really fun one. Yeah, fine. Everything's due in Newcastle, and it will pull it all in, but it also pulls in stuff. If you're lucky, you've got Wikipedia articles linked to it here, so you can get all that data and use it. We're using it for a product called Metalock, where we're doing a lot of textual name matching. And so it's a really, really good data source if you want to build your own geocoder or whatever it is you want to do. And lastly on this one, this is by no means exhaustive, but it's a really interesting one. It's a company called Geolytics, who probably about the size of Earth, they're probably smaller than Earth, actually. They're a geo consultancy. And quite often what we're asked for when we do postcode maps is people want to plot sales data or whatever happens to be per postcode, and everyone automatically assumes that postcodes do have a geographical boundary. They actually don't. They're just a point. They've never been anything more than that. But the Ordnance Survey realised that people get this and want them to be something they're not. So they sell a quite expensive data set where what they've done is worked out from the point-based information, using something called Veroni, they've worked out how to equally share the area between 2 points of a postcode between those 2 postcodes and all the other surrounding ones. If you do that Veroni thing on all these points, what you get is these kind of triangular, weird, very low-res areas, but they're as valid as anyone else's. What Ordnance Survey and this company called Geolytics have done is to then pull those to match natural boundaries. So they'll follow a road that's near the edge of what they got out of the Veroni thing. They'll follow a county boundary or a voting parish boundary or something like that. And so what Ordnance Survey did that with their data. What the guys at Geolytics did it with OpenStreetMap data. So what they produced is something that is completely different than Ordnance Surveys, but just as valid, because it's all nonsense anyway, but it's great for visualizing data with, and it's kind of roughly right. And so they offer it for completely free. You can download it. I think the idea is that if you want it to be updated then you go and pay them a very, very reasonable cost, and we've used that in a number of different projects.
What's Where's Louise?
What's Where's Louise? It's probably, I'm guessing, tracking one of their people. Or is it just a blog? It's just a blog.
It's like, where's Brian?
Where's Brian? So that's a bit about open data. Kind of leading on from that, we've all been probably using Google and Bing here and various other places, so we know about the commercial, really well-known mapping providers. What it's worth talking about, and Mapbox is now becoming one of those well-known providers, is other alternatives. So I think a lot of you have probably seen Mapbox. This is Mapbox. It's based on OpenStreetMap data, but as I said, OpenStreetMap is just a data source. You need someone to provide the rendering of it and the services evolved around it. Mapbox have basically been a brilliant example to the technical community of how you should sell open data and what a sensible business model that everyone loves is around open data. So they do an amazing job of rendering OpenStreetMap data all over the world, and they have some great tools where you can go in and say, well, I want streets to be a hideous colour, please. Not sure quite what that changed there. Should change in real time. Yeah. I want buildings to be hidden, etc., etc. And then you can then take this custom style you've built, and they provide a whole load of tools for you to use it in different mapping projects. But you can then take this custom style somewhere or other. Can't really get it out there. Somewhere you get the ID for this style out and you put it into your code and it will just magically appear. So this is all being rendered on the fly. It's a little bit simpler than it looks because it looks like I could choose absolutely everything and it's going to the raw data to do it. Actually, they're sensibly cheating. What they do is they render every element you can style as a separate transparent layer. And then they tint that layer and combine them back together again for you. So it isn't coming from the raw vector data all the time. It's coming from those layers which they've done out.
That's very slow.
Not compared to rendering it from the vector, no, especially with the whole worldwide. Mapbox have done some great things on top of that, so that's obviously free data they used, provide a service on it, but they've also got some great styles that are around terrain. So terrain is where you're trying to focus on geographical features more than physical features or human features. So you can see they've got nice kind of hill shading and contours on hills. But they also have worked with some satellite providers, either in the States, free government sources like the agricultural, whatever they would call it in the States, the government organisation that do a lot of photography for crop stuff, and so they've used that, or they've licensed it off some satellite providers. So actually for UK, I think their aerial imagery is just as good as Google's or Bing's in the vast majority of places. I mean, that is crystal clear, sorry. And the whole UK is like that. The coverage is very, very good. So Mapbox's licensing and pricing is very, very competitive when you compare it to a Google or a Bing. And for a lot of their stuff, especially the stuff based on OpenStreetMap, what you can do with it is a lot less restrictive. So you can cache it for offline usage, which you can't do on Google or Bing. You can do all kinds of different things with it.
Do you have price comparisons somewhere?
I don't, because it's not possible to do. Mapping licensing is possibly one of the most complicated licensing I've ever seen in the world, because there's so many different variations about how you're using it, when you're using it, what you've brought along with it, that you just genuinely cannot compare like for like. It's not possible.
So how do you know that it's cheaper?
How do I know it's cheaper? Because I understand all the gamuts of the licensing. So what I can't do is I can't show you. What I can do is I can talk you through it. And actually, we get a lot of business out of people ringing up going, I don't understand. Help me understand what I can do. So we've kind of done it from that. MapQuest's great claim to fame at the moment, and I'm really hoping it might do this, but I doubt it, is Mapbox, sorry, is that they update from OpenStreetMap every 5 minutes.
Wow. So we should see that change.
So we should, hopefully, but I haven't seen it actually be that quite quick yet. Let me turn the buildings off, didn't I? Can I reset style? We should see that building now drawn on there. I have seen it do it with someone else. One I did the other day took about half an hour.
No.
Not the aerial imagery. Although the aerial imagery they claim they process in half an hour from when they receive it. List of the buildings turned on. No, we've just not got any buildings drawn there yet. Okay. Hopefully, if we come and look at it at the end, and oh no, it's there, look. There it is, yeah. How cool is that? So your actual map that you'd be using on someone's device or whatever would have updated in the time I've been talking since we drew it. I think that's a pretty amazing pipeline they've got going there.
Looks like you live in the middle of nowhere.
That's reasonably accurate.
A large plot of land around.
So another provider that who've been around for a long time as a commercial provider are MapQuest, but they're mostly known in the United States. But what they did a couple of years ago was provide an alternative product to their commercial product based on OpenStreetMap data again. And actually a lot of people, because you can use their tile servers for absolutely free, they don't even have a paid version of it, and there don't seem to be any usage limits. So it's getting used by quite a lot of people. There's not the flexibility that you get from Mapbox in terms of styling, but it's a nice, pretty common map style. But obviously, so if you want to use something for free and you don't want to pay Mapbox anything, it's a great alternative to go and use, but you've got no guarantees about how long it will stay there and that kind of stuff. But part of the great thing about OpenStreetMap and the kind of different providers, as we've shown recently with BARM-CTU, is they all use the same code, they all use the same way of doing stuff. Even Google and Bing use an almost identical way of doing stuff, so flipping one out is a half-hour task, not days and days of rework. OS even have a base map service that is free and they will render for you. Again, has various license uses, but you can use it commercially, called OS OpenSpace. And obviously it uses only the UK and it uses their map styles. It's fair to say most of their map styles, as you can see, are really not designed for the web and haven't gone any further than that printed atlas your mum and dad used to use in the car. Until you get down to this level, this is really their first attempt at a web sensible style, which I think is fine. But you can see what they're showing here is all those free data sets we can download, because yes, we've got buildings here, but they've kind of generalized them. They're not each individual building, so it isn't the really expensive data set, but for most usages, would be great. So you can use this for free. It's got a geocoder built into it, and there's various different APIs and toolkits for using it. Which brings us on to mapping controls. See if you can guess what this is about. That's the one. So when we use a control in a page or a mobile application, we've kind of got this choice between whether we use native controls, so those built for iOS or desktop or whatever, or where we use web controls.
I was going to go Apache.
And there are lots of good reasons to do one or another, but it's fair to say over the last 2 years, all the map controls have really been working on getting their web-based JavaScript controls working really well on mobile, supporting touch, being fast, being responsive. So it is getting much more difficult now to choose project what you do, and actually sometimes when you look at what looks like a native control, quite often people have just wrapped up the web control and made it a little bit native. So the lines between it are blurring. They may be about to unblur again because of some developments that are happening with mapping. They work very similar at the moment because everyone's using these tiles, these 256 pixel images, which you can work on web or whatever. Everyone's starting to lean now into looking at doing vector-based tiles where you just give the raw data and the browser renders it. Now that's going to be a lot easier to do in a native control than it is in a web control. And so if you go and use Google or Apple Maps on a device now, they are actually rendering live on your device using
SVG
vector vision. Some kind of proprietary stuff, I think. So it means things like labels will turn around as you turn the map and all kinds of funky stuff that you can do. So it is the future, but web's going to take a while to catch up with it because you've got to worry about cross-browser. So in terms of web mapping, there are two really good controls that work on web and mobile that are open source. So you can use your Google and Bing and they all work fine. One's called Leaflet and one called Open Layers. Open Layers is the granddaddy and champion in the way. It's been around for a long time now. Does a lot of stuff, a whole ton of stuff, and it's actually used. It was traditionally used by the vast majority of open source projects. So Mapbox started using it, I believe, originally. OpenStreetMap, the site, the editor, we used to use it. But then about 3 years ago, cocky guy from Eastern Europe decided he didn't like open layers, and when he was working for CloudMade, Mapbox competitor, he completely lied to them and then went and built a control in a weekend that he thought was better than the reigning champion. And it turns out he was probably right. And he spent a bit longer at CloudMade writing Leaflet and eventually made it completely open source and doesn't belong to anyone. Leaflet is not as complete as OpenLayers. It doesn't do as much stuff. OpenLayers can do some really clever stuff to do with mapping and stuff, but it does 95% of everything we'll ever want to do with mapping, and therefore handles 99% of every map out there in the world. It does it in a much smaller footprint, tiny bit of code, very, very fast. It handles data way better than Google and Bing, as Rob will attest to, and some stuff we did. And everyone has switched to it, basically. So Mapbox use it, and in fact, Mapbox hired the guy who wrote it, and they now mostly contribute to it. OpenStreetMap, what we were editing in was Leaflet with a whole load of stuff. So it's very, very cool. There's a million plugins out there for it, and I really wish at least Bing would stop using their control and use Leaflet. I see. That said, there are some native controls that have some good reasons for using it, and you'll see a trend coming here. So in the iOS world, there are two really good controls. There's one called RootMe, and there's one called Mapbox iOS SDK. Really catchy. RootMe has been around for a while. It lets you use any provider like Leaflet does all kinds of things, but it's nicely hardware accelerated on iOS. It's good enough that basically Mapbox, as they did with Leaflet, decided they weren't going to write their own, and they just forked RootMe and added their services to it without much code. So it's very, very light fork. It's just a little bit on top of it that means.
Do they keep merging from?
Yeah, they contribute back to RootMe and then they pull from RootMe. So anything they're fixing in RootMe, and it's just really more convenient to use their control because it just puts all their stuff on automatically for you. But really good. Android, there is something called OS Android, similar kind of thing. Strangely, Mapbox have forked that and built upon it. So there are other controls, but they're kind of the two that seem to be actually popular and getting used. But there aren't too many applications, I think, these days where it's a clear cut what you should use, native or the browser-based one, even when you're doing an actual native application.
So those maps like Android SDK, you would use for your website, or you would use for native applications?
So these two are for native. That's what you'd use for web or mobile web, whatever you do.
Okay, so if I create application for iPhone that would work also on Android,
then you'd want to start using something like Leaflet native layers. But if you wanted to usually the reason you'd use these is the performance is getting a problem. You're plotting millions of push pins, but you should be questioning why you are, or really complex boundaries, or all kinds of stuff. So there are reasons to use the native ones. It's just they're decreasing over time.
Is Google still running on SVN, Google Code?
I don't know. Right, Map Ninja tools. So that's the kind of how you visualize your stuff and how you get it onto someone's computer. But there's a whole load of work that we're increasingly doing that is around manipulating the data before we get it there, or building those tiled layers that you present to people. And so I wanted to go through four, not quite tools, but four bits of stuff that we use. The first one is actually both an organization and a distribution of tools, I guess, called OSGeo. Basically, it's an organization that tries to bring together the best of the open source GIS world, write documentation, run training, and promote it. And what they do is they distribute a Linux live CD, so a CD you can just put straight into your machine and boot from, and it has everything set up for you. So loads of tools that we'll also talk about in a minute, loads of examples and tutorials. So it's a great way to learn all the different tools that are available open source. So at least two of the next two tools are definitely on there. Don't think Tilemily is yet. The next one with a Q with a line through it is something called QGIS. Used to be called Quantum GIS. Everyone hated saying quantum again and again, so it's now called QGIS. QGIS is your kind of data manipulation workhorse of the open source world. There are at least two or three other competing products that are commercial. So Esri are probably the most well-known GIS software company in the world, charge a lot of money for a product like this called ArcGIS. There's also something called MapInfo from Piggyvos. There's a few other different providers, but QGIS is entirely open source, has a massive plugin framework all built in Python, is good enough. It's not as good as ArcGIS. It's not going to be, let's face it. But for everything I do, I really don't need to go anywhere else with it. And if I do, then I should go and contribute to it because it's really easy to write stuff or write plugins for. So the kind of things you can do, I've loaded in a common file format here called shape files. I've got the whole world in here, and I can take a little while to render because that is a 500 meg file it's loading in here. But you can basically then go in and add new shapes. You can run some processing if you wanted to merge countries together. You could export things out of it. You can convert into different file formats. It does pretty much everything you might want to do. So we use it for all kinds of different things, like taking just particular countries out we want to focus on, or fixing issues, or whatever it happens to be. So it's a great desktop-based editor, and does a whole load of stuff that I won't even attempt to go through all the kind of things it can do. Another thing that I've done that's quite useful actually is it can take aerial imagery or whatever you'd want to put on a map background and do what's called rectify it, which is basically telling the program that this point on my vector, on my raster image or my aerial image, is this place in the world. And you can put 4 or 5 different points on your image, and then some code in QGIS will warp that to the world. It will make it all fit properly so that you can display it. Because obviously when you take it out of the plane, you're at an angle and some of it's got perspective that far away, and you've got some distortion from the lens. You can't literally just take that image and plot it, especially as when you're taking a picture, you're doing it on a real globe, and then you've got to go and put it on a flat surface. So it does a lot of clever maths to do that. As QGIS, GDAL, most of the clever stuff QGIS does, it uses GDAL to do. GDAL is a DLL compiled in every platform under the sun that does tons of geographic transformations, and lots of tools are built upon GDAL, and it's got a load of different tools to do it. We quite often use it for importing data into SQL Server. It's got something called OGR to OGR, which is part of GDAL. It's used to do that whole transform warp aerial thing behind the scenes. It's just a command line therefore I hate interface to everything that you possibly want to do geo, and it's used by a whole ton of commercial tools behind the scenes without you knowing it performs pretty well actually. It's quite old, it's been there quite a long while, getting improved. Mapbox is probably my favourite tool at the moment just because it's so fucking cool. Mapbox decided that as part of their offering, where is it? As part of their offering, obviously you can just go and use their data and OpenStreetMap data and get your tiles, but you might want to have much finer control on the styling that they do, or you might have your own data that you want to put into it. You might draw in your own stuff or whatever. TileMill is a desktop program that I think if you agree when I mess around with this, and it all feels and looks like a real desktop program, but it's all written in Node, runs on every single platform, and that's a web page, which is amazing when you get behind it. But what it's doing here is I've got a whole load of OpenStreetMap data for Washington. It's imported all the different data things like roads, bridges, motorways as separate shape files, which is a common geographic format. It's put them all on the map, and then I use something that looks a lot like CSS, or even more like LESS, which is a kind of hybrid CSS. It's actually called Carto CSS, and it's forked from LESS, which is why it looks like LESS. But what it means you can do, what should we do? It means in my desktop-based thing here, I can, let's go and change motorways to be bright red, which is my favourite debug colour. You change something here, you click save, and it tells you that you're a Muppet, but not before a developer does.
Get programming for the win.
And there we are, it's re-rendered. So unlike OpenStreetMap, where it was doing some clever stuff, this is actually running on my machine right now. It's running a full OpenStreetMap stack. I've done the whole UK in this on my desktop machine. It will be slightly slow on my laptop here, but that is rendering in real time. We can go and find row, what can we find? Labels. You can even change fonts to your local machine. It's very, very cool. But as you can see here, it's got some, it's using some of the selectors that you can do in LESS to actually style differently depending on various variables, like zoom level, for example, here. So you can have zoom level changes, you can have all kinds of different things. You pull in labels, for example, from that's telling it to get the name for the label from a field in labels called name. Right. Really, I mean, it looks a little bit complicated, but actually, once you go through the tutorials, it's a piece of piss for anyone to do. They're actually aiming it at journalists and people like that, because you can come in and create a really simple map. Once they've got all kinds of things.
Are they going to bring out an editor so you don't have to do it as CSS, so you can just edit it like on the website?
I don't know. They're working on a second version of this at the moment that's very much focusing around vector tiles. That's a work in progress. I'm not entirely sure how they're getting on. But actually, again, this is actually just a big collection of a whole load of open source tools. They haven't reinvented everything here. What it uses to render the tiles is something called Mapnik, which is what OpenStreetMap basically produced to render their tiles, and everyone uses. This is an example where you've got a nice, pretty kind of looks like a folded map, and they've got the colours of the country are being selected by the ID of the country. So depending on what the code of the country is, they've got different colours. So it's very, very cool, and they've got this being put in and the interactivity. Once you've got it like that, Mapbox can then upload it as tiles to Mapbox. It will render it on your machine and upload all those tiles to Mapbox. You can start serving it. It will do it out to a PNG, just to use a swing, or a PDF. It outputs it to an SVG, which you can then take into Illustrator and do a massive print, whatever you want of it. It will output it to something called MB tiles, which is actually what Mapbox use for distributing tiles around. So imagine you've got these 256 pixel tiles. If I rendered this, you'd end up with about 4 million tiles, and 4 million less than 1K files sitting in an operating system tends to kill it. So MB tiles is SQLite, for those of you who know what that means. They just dump all those tiles into a SQLite database, and that's what you upload. So it's much easier to upload one big file, and it performs a whole lot better. And you can actually take this style out as a Mapnik style sheet and put it into Mapnik, this tile server, and never touch tile. So you come in, use TileMill as your editor, and then chuck it into Mapnik. So it's a very cool tool. We're using it for lots of stuff. It's partly why I want to go and buy a massive developer machine, because it took me 22 hours to render something the other day, and that wasn't very big. But what I did find, out of interest, is I haven't really shown you here, but these are all shape files. I can actually connect this to a database, which we'll talk about in a moment, rather than these static files, and then this thing performs a whole load better, because it can do things like only get me the data that's in the viewport and stuff. Very cool. Brings me on to, that's great for doing editing of stuff and moving things around, but sometimes you need to do some analysis of the actual geographic data you've got and do some clever stuff with it. There are a number of different flavors of ways you can do this, but in the world that most of us know, pretty much all the major databases now support in some way, shape or form bits of spatial querying. And that means it understands geographical data and it lets you do some clever stuff. There's quite a good standards committee for geospatial stuff. I'm trying to remember what they're called, but now I can't do a second. And they came up with a whole load of standards for how you should query geographical data. And everyone pretty much has interpreted them perfectly and implemented them. So if what you learn to do in SQL Server, in terms of what functions you should call and roughly how they work, translates directly into all of the others. Not to the point where you can copy and paste the SQL, because that's dreamland and unicorns. But at least you can look at it and go, oh, I should move that one over there, and I should move it around.
Have you tried RavenDB spatial data support?
I have, yeah. RavenDB has a very small subset, but pretty much most of the stuff you're going to want. Because mostly it's used for distance-based stuff, and ordering by distance and querying stuff within a radius of a circle, that kind of stuff. It does actually get misused a little bit, because people think they need to use all this spatial work to tell how many pins are within a window. But obviously, as you've all learned working with me, that's just a between query, and a between query will run about 900 times faster than any spatial search. So I'll show you an example of what you would want to do that for in a minute. So SQL Server has had it since 2005. Oracle probably has the most complete and performant, but obviously comes with Oracle's price. Those of you who've ever used a database called Postgres, which I know these boys over here love, Postgres has a add-on called PostGIS, which supports pretty much everything the SQL Server does, in fact, probably more. Runs really well and is used by the vast majority of the open data community in terms of mapping. So it's used way more than any of the others that I thought for the kind of stuff we do.
It runs better than Postgres does.
Well, it is Postgres underneath, but so that's it. And the last one here is a bit of a strange hybrid. So it's another company that's innovating like Mapbox are called CartoDB. So what CartoDB decided is that getting Postgres and PostGIS set up and hosted and actually running stuff against it and getting into it was a bit of a ball ache for your average person. So they built an interface over the top of it, and they sell a service that does it all for you. And I'm hoping somewhere in here I've got CartoDB. I've got one open somewhere. Come on. Log into my account. So you can come here. You can use 5 tables and 100 meg for free, which is fine for a little pet project. It's not cheap as you start to scale your data, but it's probably still considerably cheaper than running it all yourself. And let me show you what you can do and why it's so friendly. So I can come in here, I can create a table. It lets me upload a ton of different formats, whether that's a CSV or a shape file or a KML file or a GeoJSON file. Some people know what that is, some people don't. And it looks like Google Spreadsheet, so I can come in, I can edit any of these values relatively easily. I can import new rows and add new rows, but I guess the bit that's interesting about this is we've got this geometry column where I have got some building outlines. And so I can visualize this data on the map. It will even, I think, tell me when I click it information about them, which is fine. It means I can store some geodata. It gives me a little thing to visualize it. And CartoDB does have some kind of publishing wizards that will let you create your own simple kind of data-driven map that you might share with people. What we tend to use it for is it has a REST-based service behind all this that you can run SQL queries, Postgres SQL queries, via the web service, and it will return all this data as GeoJSON for you. So for us, rather than setting it all up, we just run this and plug it into our JavaScript map, and there we are. We didn't have to do anything.
Begging for SQL injection attacks?
No, they're very well done on how they do it.
Okay.
Let me show you an example of why.
Go test that.
Yeah. I'm going to go kill Bobby Tables going.
Let me show you an example of what we're doing here and why you'd want to use a spatial database. So I've got those, let's in the wrong one. I've got those buildings in one. In another one, I've got every railway access point in the UK. That means where you can get onto the railway if you're a railway engineer. And what I've got in here, you see I can just open up a query window in here. It might not make sense to you what that is. I'll briefly explain what it is. What I'm doing is loading up a line, a geographic line that I've drawn in another program. That line goes from Potter's Bar just up to Stevenage along the A1, very, very roughly. And what I'm saying is, please load this line. This is the projection, so it's to do with how it actually should be rendered. And I'd like you to buffer it. So this ST buffer is one of these spatial queries that everyone has fulfilled in the database. So it's the same, works the same in SQL as it does everywhere else. And I'm asking it to buffer it by, I think that's in kilometers, this value here. So I'm saying draw, on this line, draw a big caterpillar around it. So expand that line out to be a much thicker line by that distance, please, all the way along the line, no matter how complicated it is. And then I'm saying ST intersects. So I'm saying for all these access points, find me all the ones that are inside that buffered line. All right, so if I run that, which I think it probably is, there are all the access points in the UK that are within that distance of that line. Right? That's a non-trivial query we've just run there. Don't even try to imagine how that actually works behind the scene. And that's actually quite a simple query to be able to do. You can do much more complicated buffers and unions and all kinds of stuff. But if I take the query off just to prove that I'm not talking crap, if I take that bit off and run it again.
What are those points? Towns?
No, they are points along the railway, hence they seem to follow motorways. They're actually following railways that you can get on. So it's where an engineer can go and open up a gate and walk onto the railway.
Yeah.
So there's all the ones in the UK. and notice actually it's performing not crappily here because they're doing some clever stuff. But our query went and found ones in a very specific and quite complicated query, and it ran in very real time. So it's a brilliant tool for this kind of stuff. I'll show you some other stuff it can do later, but it's really, really good. Can be used reasonably by a novice-ish user. Certainly a Power Excel user like Neil will be able to come into here and not run what I run there, but their wizards will take you through some quite powerful visualization.
Test that, see how Neil can handle it.
Right. Does everyone get a feel there for why you use spatial databases and what we've got there? Mm-hmm. Right. So we'll talk about visualization. So I started to look at that a little bit with CartoDB because it's got some tools for doing this. You might not just want to draw it on something on a map. You might want to come up with some cleverer visualization. And there's two good libraries for this. One called D3, which some of you may have used. It's a JavaScript charting API, but it also has a whole load of mapping functionality, which I'll show you in a sec. And one from CartoDB called Talk, which is the other coolest thing in the world. So let me show you D3 first, which hopefully D3 have a very cool site, unsurprisingly, with all the stuff they've got. Not that one. Where the example's gone. Examples there. So as well as all this charting, they have some mapping stuff. And the reason you use D3 rather than a dedicated mapping thing like Leaflet, I'll show you Veroni because that makes sense, is because D3 doesn't have to do all the zoomy, panny, scrolly stuff, so it actually performs very, very fast. It can do it, but because it's specifically about visualization, it just does a better job. You know, I was telling you earlier about how they got how you get an areas out of postcodes, this Veroni thing. That's a Veroni of all US airports. So it's kind of like the airspace around every airport, just made up by sharing equal boundaries. So you can see this one is kind of equally sharing the area around them. But that's all being done in JavaScript in that library in real time.
So every single one of those points an airport?
Yeah. And there's all kinds of interactive stuff they can do here. Why you'd want to? Don't know. Choropleth maps, which is to you and I would know as a kind of thematic map. But again, all of this is vector. None of this is rasters. This is all being done.
What's that show again? It's pretty A-level geography.
That what choropleth? That's
unemployment rates.
No, what is that particular type of? What does choropleth mean again?
Choropleth means that you've got a value that's being displayed per geographical area. So in this case, it's like counties and states.
This one is employment.
There are tons of different ones in here that you can find for maps.
Oh, it's the shading. That's what.
Yeah.
Oh, non-contiguous cartographs.
Just example.
So these are where you can plot. This isn't a very good example of it, where you can alter the area that a shape covers depending on the value of your figure. So people have used it for doing things like plotting world wealth, GDP, where all of a sudden the United Kingdom looks much bigger than it should be, and Africa looks like this small little island down there. So it's complete nonsense, but it's a really quick way of visualizing to people stuff that's around area versus values. So it does some really, really cool stuff. Talk is built on CartoDB. It's a completely open source library. You can go to the GitHub repo and get it. And it's for visualizing temporal data, so geographic data that has a time-based change in it. So this one is naval shipping pre, during, and post World War I, I think it is. And each one of these things is a ship checking out of one port and checking into the next port, and then it guesses where they went in between. And so you can see along the bottom here the time as it's going through, and it all visualizes, which is nice. We've all seen that. The difference with Talk is this is all rendering now live on my machine, right? And if I zoom in, it will start to re-render in a second. I can alter everything I want about this. Come on, faster. So again, if you look up here, there's this panel that looks a lot like CSS. It is again using Carto CSS. And Talk has added an ability to filter by time frame. So where it's got this value 2, value 3, value 4, what that's saying is you get this trail by by being able to separately style each previous frame from the current one. So the lightest dot on there is July, and then it will go back one and style it differently, back one and style it differently. So each one of these is previous keyframes. So that's saying go back 2 keyframes and make it that color, go back 3 keyframes and do it that color. So what you can do in real time is change anything. So I've changed the marker size there. The first dot will now be red, the others will carry on being the color they were. You can change everything in real time and it will re-render. You can go and put in how long the animation should take, how many steps it should have, all kinds of, and you can link it to a CartoDB table. And they've now actually built this into that nice pretty interface I showed you earlier in CartoDB, where you can just get your data, go to the wizard, go, I want it to be temporal, please, and it will start doing all this stuff. But there's nothing stopping you taking this, creating your own data source that matches their format and using it with whatever you like. I could plug this into SQL if we wanted to with a little bit of work. It's very, very cool. It's fair to say I haven't figured out what to do with it yet.
Yeah. Are there any other examples?
They've got.
You said that with tube trains in London.
Yeah.
Live running tube trains where they just update the data as they go.
They've got an example which I won't try and find now because it'll just fail. Where it's got a race car going around the Nürburgring, and the style is based on how fast the car is accelerating. So as the car accelerates, the blob gets bigger and smaller as it decelerates, which does actually, even though you can see the acceleration, deceleration because it's moving this way, it adds to the visualization. So I'm trying to work with the client at the moment to plot disease outbreak using this and show things like dengue fever over time and the Ebola stuff over time, which would be quite nice. Now, obviously, this is not an analytical, detailed scientific tool. This is very much about taking a really massive data set and making it understandable to the general public. So it's very much about visualization.
Thank you, Broker.
No problem. All right, I think this is the last one, and hopefully most of you know these. But we'll see. There's some mistakes, very easy mistakes that web developers make when they're working with maps. They used to make a whole load more, but because we've got into a world of data services and JSON, that people get a bit more. There are less problems. So this used to have a whole load more things like enable gzip if you map it and don't use XML. It's verbose. I'm presuming we all know that now. So where GIS data has some things to add to that. One is obviously every line and point and polygon we've looked at today is basically a big array of latitude and longitude points. So 2 values for every point, and then all in order to draw a polygon or to draw a line. Your latitude and longitude, especially if you've got it off a mobile phone or whatever device, will come with a varying number of decimal places after it. Quite often it will come with 19 decimal places. Okay, to give you an idea, who wants to guess how small an area is 6 decimal places on latitude and longitude? Now, it's cheating a bit because it does actually change where you are in the world. I won't bother explaining that, but only very interesting. 6 decimal places, what do we think, what accuracy is that?
Like 10 meters or something, a meter.
So that's my mouse. That's about 6 decimal places. 5 decimal places is sub-meter accuracy. 6 decimal places is some crazy amount of accuracy, right? People pass around 19 decimal places to draw a blooming line across the UK. It's like, how accurate did you want to be there? So most people, when I go and look at the stream that's coming out of their applications, are passing around, I don't know, 800% more data than they need to, because they didn't put a round around their figure. So you can just go into your code, put a round around it to 5 decimal places, and for most mapping you're doing, unless you're working for an engineering company, that is going to be plenty fine. And all of a sudden, your payload is 1/10 of the size it was 2 seconds beforehand. So definitely make sure that you're using precision that it makes sense for you to use. You still want to store with that much precision potentially, because you want the option to go back later and decide you've changed your mind and you want to be that accurate. And you're not transferring it, so there's no massive value in making it much smaller. GeoJSON. Everyone know what JSON is? Probably not everyone. Okay, I can JSON. JSON is a file format for transferring data around mostly coming out of the JavaScript world, but now used by everyone, and it looks like that. So you might not understand code, but you can see basically it's got a name and a value for pretty much everything you want, and there are ways of nesting them to provide different things. It's a very simple file format. It's very, well, it's not very succinct, but it's succinct while still being readable to a human, and therefore it compresses and doesn't have a whole load of stuff you shouldn't have. All GeoJSON is an agreed format for JSON data for representing geospatial data. So in this one, it is got a piece of geometry, which is a point which has a latitude and longitude, and some properties for that point where the name is Dinagat Islands. There we are. And so there are agreed formats for polygons, line strings, multi-polygons, which is where you've got collections of polygons and all kinds of stuff. But all those tools we've looked at today, CartoDB, QGIS, etc., are now tending to use GeoJSON as a good way of transferring data behind them. And so certainly what we kick out of our services when we're doing a map should be GeoJSON, and there are libraries for doing it. But you can see it's pretty simple. TopoJSON. TopoJSON is cool. What someone realised is quite often, I really don't want to load the file, I'm going to try and load it in here. No, that's okay. Quite often when we're doing maps, what we're plotting is territory-based maps, so that cartograph or the chloropeth map that you saw earlier, where you've got all the states in the United States and they all touch each other. And what someone pretty quickly worked out is that if you represent that data as individual polygons, as JSON or whatever it is you want to put it into, you're going to end up with a line between two areas that connect to each other, repeated twice in your data, because you're going to have a line in this polygon and a line in that polygon. But you don't need it because they follow both that line. So someone came up with an agreed format called TopoJSON and a library for taking GeoJSON, converting it into TopoJSON, that works out all the lines that are shared and only transfers them once in the data. And then it gives you a JavaScript library which turns it back into the format that everyone recognizes on the client. So you're only transferring, again, a very small amount of data.
So a lot of lines attached, like in the USA and States, you could end up practically halving your data.
Oh yeah, yeah, easily. I'm guessing I might have killed this machine because I did throw 500 megabit. Someone created a, bizarrely and amazingly, an online here. Someone created an online tool, all in JavaScript, that takes that code, because it was written for Node originally, and makes it work in your client. So you can load a shape file or GeoJSON file, or whatever it is, into your web browser, and it will do all that conversion. Come on, please.
Are you uploading it to that website?
No, it's all doing it in the client. It's very impressive, but it is still 500 meg of data. I can get to a smaller one very quickly. That'd be helpful. But I don't think I've got postcode one.
Just wait for it.
Yeah, anyway. And it does it all in your browser, in the client side, and then you can. Come on, I really want to show you one. Let's go to G-Physics and get this.
Can you get it open on your machine? In the other room?
No. It's just I reinstalled this laptop since I last gave a talk, so I don't have the data here now. I'll go and get that postcode, but I can't skip one. It could be anywhere, but I have no idea at the moment. Come on there. That's not going to be so good, is it? Meanwhile, it might have loaded. I want to show you this, it's very cool. But yeah, it does it all in the client, but what's even cooler is that you can then do what's called simplify or reduce, because I'm loading up in a minute 183 meg of code data. You probably don't want, again, that accuracy most of the time. You're not going down to the line, especially if postcode data is not accurate anyway. So this tool in your browser, again, called client side, will simplify those lines whilst making sure that they carry on touching each other. So if you imagine you took a polygon, the easiest way to simplify it is you take out every other point, because it will still roughly represent it, and you carry on doing it, take out every other again, take out every other again. Obviously, there are better simplification models that try and keep the rough shape, but the one a lot of them struggle with is where you've got two that touch, because if I simplify this one, and then I simplify this one, the boundary won't match anymore. So they don't stick together, so you end up with a stupid map with loads of holes in between. And this on the fly in JavaScript, again, using some of the stuff from topo.json, it splits them all into lines, agrees where the lines are the same line, simplifies the lines, and joins them all back together again. So what you end up with is a simplified, all still sticking together map of it, all in your browser. But it does it so fast, you just slide a scale and you see it being simplified in front of you for the whole UK postcodes. Graham and I, in fact, I think you played on it as well.
Yeah.
It is awesome. And then you just go and download it as GeoJSON and off you go. So you can get all the command line tools and get a node working and use what this is actually using behind it, use the topo.json files. But if all you want to do is save it once, then just go and use this online tool. It's a much easier way of doing it.
But make sure you have a better broadband.
Yeah, well, we'll make sure you've got the file, because it doesn't. That's what I'm saying. Is it runs all of this in JavaScript on your machine. It doesn't upload anything to their site at all. Okay, cool. Anyone got any questions about any of that? Because that's the end.
Yeah, which maps are you using so far, like in Skype and other projects?
So we call what we do at Earthware mapping agnostic, as in we will use whatever it is that works best for a particular project. So my preference these days, unless someone wants really good aerial imagery or street view or very, very high detail data, is to use OpenStreetMap, Mapbox. Mapbox, in terms of their hosting and their quality and their support, is just as good as Google or Bing. But there might be reasons you want to use Google or Bing, because Bing have the best aerial imagery in the world for most of Europe. Google has Street View. Really, no one else has anything sensible like Street View. Google are starting to do some more innovative things with points of interest and vector maps and stuff. Or you're on a mobile device where using those frameworks is generally free anyway. So usually our decision comes down to who the client is. When it's Skype, you kind of have to use a Microsoft product, or who's the best for the job. So TfL, they paid us to spend about a month figuring out who they should use and who met all their requirements. And in the end, we said Google or Bing, because they both do it, but Bing's going to be a lot cheaper. So they said, fine, accepted, we'll go with Google. Which is fair enough, I didn't really mind, because it probably ended up being better for it, but right. Drag.
ISO's map, what do we use for that one?
So for the one that Anthony's just done, we're using leaflets and Mapbox tiles. And for the product that we might build with them,
Doesn't seem to. Can you drag it?
yeah, you definitely can. The one we're about to build with them, we'll probably use leaflet again. It just is the fastest by a long way for a lot of stuff we want to do.
Achievement unlocked.
Oh, come on, work today. Why aren't you working?
It's the right sort of one.
Magnet.
Process is not
I'm going to rip out a page of Justin Bieber book and we can put it on the dartboard.
Anyway, any other questions? Interesting?
Yeah.
Are we getting it uploaded somewhere, the video?
Yeah, it's recording at the moment, so I shall go and stop it now. And then it will work perfectly afterwards, right?